Alright, in example 3a. In this video we're going to go over examples 3 and 4. So in example 3a, using the angle of depression. So the first two examples we looked at angles of elevation. Now we're going to look at angles of depression. An airplane pilot sights a raft at a 26-degree angle. The airplane's altitude is 3 kilometers. What is the airplane's total distance from the raft? So once again, we don't have a picture, we need to draw a picture. So these don't have to be any very detailed, just draw, basically set up your right triangle. Now, I'm going to put point A, which is going to be the airplane is up here, and then we're going to have the raft down here. Now, the angle of, or the line of sight is from here to here. Now, the things we know about this. We know that the pilot, or the plane, has a height of 3 kilometers above the water. So this is going to be 3 kilometers. Now, the angle of, if we're looking down upon here, this is the angle of depression. So this is not going to be your angle of depression. Your angle of depression goes from your line of sight. So I'll draw that here. Maybe yellow will show up here a little bit. There's our line of sight. Now, we will, this is our 26-degree angle. 26 degrees up right here. Now, because we talked about this earlier, we can either draw another line over here to represent our 3 kilometers, or we can just put our angle of depression into an angle of elevation problem. Because as we looked before, because of alternate tier angles, an angle of depression is the same as the angle of elevation from the raft to the airplane. Now, we're looking to say, what is the airplane's horizontal distance? We're looking for the distance across the horizontal, which means this distance here. So, this means that this becomes our x value. Not looking for the line of sight. If it said how far was the airplane from the raft, you'll be looking for the line of sight distance. So you have to pay attention to what they're asking for. This is in depression problems, can be a little bit confusing. So we're going to use our trig function. We do not have the hypotenuse here, so therefore we're going to be using tangent again. So we have a 26-degree angle. We have the 3 kilometers here, and we have x here, which means we're going to use the tangent of 26 degrees is equal to, now it's the opposite of 26, that means it's going to be the 3 on top this time and the x on bottom. So as we cross multiply, we get x tangent 26 is equal to 1 times 3 is 3. And then we have to divide by the tangent of 26. And x will equal 3 divided by tangent of 26. So let's take our calculator, and we have 3 divided by tangent 26, and we get 6.15. That means that he is approximately 6 point, and it doesn't say what we're going to round to here, so let's just round to the nearest whole number. So that we're going to say that the distance here is going to be about 6 kilometers. So he is 6.6 kilometers away from the raft of this horizontal distance. Okay, so let's look at part B. Now, you try this one and pause the video, and when you come back, you can see how you did. Now pay attention to some of the details here. The approach runway of 17 of Ponca City Municipal Airport in Oklahoma. The pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. The airport is 1,000 feet above sea level. To the nearest tenth of a mile, how far is the runway from the airplane at the start of the approach? So hope maybe you caught that. To the nearest tenth of a mile, we're given everything in feet. That means we have to convert into feet. Now, if you don't remember that conversion, it takes 5,280 feet to equal 1 mile. So, pause your video, work this out, and convert your answer into the nearest tenth of a mile. Okay, let's make one correction here. The height of the airplane is at 2,714 feet above sea level. The airport, however, is at 1,007 feet above sea level, which means to find our elevation here, how far the pilot is off the ground, we have to subtract. So we're going to take 2,714 minus 1,007, and that gives us a total of 1,707 feet. Now, because we're looking for it says the 1/10 of a mile, how far is the runway from the airplane? That means we're looking for the line of sight distance, which means we're going to be using different trig function, because that means we're looking for the hypotenuse. So if our reference angle is 3, based on the alternate tier angles here, we're going to use the sine function. So the sine of sine of 3 degrees is equal to the 1,707 feet over x. So we cross multiply. Divide by the sine of 3. Now, take our calculator, and we're going to do 1707 divided by sine of 3 equals, that's going to give us 32,616, and we're going to put 0.1997 around to 4 places here, so 32,616.1997. So now we've got to convert this into miles. So we're going to take our number here. This is going to be in feet. So 32,616.1997 feet over 1 times our unit conversion from feet to miles. So 1 mile is equal to 5,280 feet. And since our units are going to cancel here, we're basically going to be taking 32,616.1997 divided by 5,280. So since we have this in the calculator already, we're going to say divided by 5,280 feet, and it to the nearest 1/10 of a mile would be 6.2. So we get, this is approximately 6.177, so this is going to be a 6.2 miles. So the distance we are away from the airplane is away from the airport is about approximately 6.2 miles. Alright, so let's look here now at example 4. Example 4 is the angle of elevation is described as E from A to B. The depression D from B to A. Find the measure of each angle. So we have points A. If it says this is going to be an elevation, and B would be a depression, so B is going to be up here. Now we'll draw a line here that shows our angle of elevation or depression line of sight here. So the next thing we're going to do is we're going to draw a horizontal. For depression would be drawing at it, looking at ahead. Elevation would be looking at this way. So this is the angle of depression, which would be D. This is the angle of elevation. From here to here would be E. And what we know about angle of elevation depression is that the angle of elevation is equal or congruent to the angle of depression. So E is congruent to D. So that means we're going to take our two expressions and set them equal to each other. So we take 5x minus 2 equal to 6 parentheses x minus 3. Begin by distributing, get rid of the parentheses. So 6x minus 18. Bring down the 5x minus 2. Subtract 5x. And that gives us a negative 2 is equal to x minus 18. Remember to add your 18. That gives us a total of 16 equals x. And the question says find the measure of each angle. So that means we need to plug it into one of our angle measures. It doesn't matter which one you do. So we can choose E, the elevation. That is going to be 5 times 16 minus 2. And this will give us a measure of 5 times 16, which is going to be 80, minus 2, which is going to give us 78 degrees. So the angle of elevation and the angle of depression are both equal to 78 degrees. So let's take a look at the part B of this, number 4. So once again, the same type of problem, elevation, angle of elevation from A to B. So set up your drawing, solve for x, and then plug it back in to find the measure of each angle. So pause the video, work it out, and see how you do. Alright, so let's see how you set it up. We have the angle of elevation from A to B, angle of depression from B to A. So we set them equal, distribute, solve for x, get it down to 2x is equal to 18, x is equal to 9. Doesn't matter which one we plugged it into, so since we plugged it into E last time, I plugged it into D. 9 minus 2 is 7, 7 times 5 is 35. So, it means angle E and angle D are both 35 degrees. Alright, so part 3 of this video on lesson 8.4 is going to be examples 5 and 6.